How is stable power supply ensured for service lifts inside wind turbine towers reaching hundreds of meters in height? The tower service lift is primarily powered through a traveling cable, supported by a cable collection bin mounted on the outside of the starting platform for extending and collecting. Electricity flows through the cable to the motor, driving the gearbox, and enabling the service lift to travel up and down. As the service lift moves, the cable stretches or coils spirally inside the collection bin. However, this approach is only suitable for shorter towers of 70 to 80 meters. For taller towers, where sway becomes more pronounced, the cable is prone to go out of the expected route. To address this, engineers opened a large opening directly below the service lift at the starting platform and suspended the cable collection bin using 3 chains. With the cable entering the service lift from the bottom, cable collection improved significantly. As tower heights continued to increase, the cable length grew. Yet the collection bin's capacity remained limited. Engineers responded by adjusting the collection bin's diameter and height. Still, this bottom-mounted cable collection method was not without flaws, as friction between the cable and tower wall could again cause cable collection failure. To overcome this, engineers developed conical and cylindrical aprons, an innovative solution that has proven highly effective, providing a temporary but reliable fix to the challenge. With the rapid growth of wind power, tower structures have become taller and more diverse. In towers over 120 meters, new challenges arise. Cables may snag on ladder support brackets or guard rails, and even become entangled with steel wire ropes, seriously compromising service lift safety. To adapt to such high towers, engineers once again shifted the position of the cable collection bin and introduced cable restrainers, installed at every level. These devices controlled cable swing through multi-point restraint, delivering a noticeable improvement. However, this solution was only viable for towers with bottom feed power. For towers with power supply set in the middle, engineers devised a movable pulley solution, which shortened the cable's travel distance, reduced its swing, and delivered fairly stable performance. Yet this design introduced a new dilemma. Defining the restrainer's weight proved difficult. Too heavy, and the cable would be damaged. Too light, and the device was ineffective. Additional issues like self-rotation and tangling soon followed. Engineers responded by adding guide ropes and a tension device to regulate the cable's traveling route. On paper, it seemed like a perfect fix, but reality told a different story. Whether with cable collection bins, restrainers, cable pulleys, or even power winches, none of these approaches have yet fully solved the challenge of cable extending and collecting in tall towers. In practice, cable management issues still occur from time to time. What, then, is the most direct cause at its root? The problem lies in the swinging motion of the cable as it follows the service lift's movement. So our engineers asked, what if we reverse the logic? If the cable no longer moves with the lift, could the problem be solved? The answer they arrived at was the insulated conductor rail, also known as a sliding contact line, a proven power transmission solution for moving equipment, widely used in overhead cranes, gantry cranes, and other industrial applications. An insulated conductor rail is composed of a conductive rail, insulated brackets, and current collectors. Its core advantages lie in its high wear resistance, strong oxidation resistance, high protection rating, efficient power delivery, and reliable stability. Tailored for wind tower applications, our engineers redefined and redesigned a new type of insulated conductor rail, mounted along the ladder supports, and paired with 2 current collectors. It supplies continuous power to the service lift, allowing the lift to move, while the cable itself remains still. Today, insulated conductor rails are already being applied in rack and pinion service lifts inside wind towers. As for rack and pinion service lift, it has become well known for its most prominent feature: safe. With insulated conductor rail power supply replacing traditional traveling cable, it has resolved the industry-wide challenge of cable collection in tall towers. The result is safer, smoother, and more reliable operation. In addition, during the wind turbine construction phase, the service lift can be lifted together with the tower sections, enabling personnel to ride it for tower climbing. This greatly improves both construction efficiency and on-site safety. The insulated conductor rail power supply system, when applied to wind tower service lift, especially in high towers over 140 meters, has so far proven to be one of the most suitable solutions. Yet it may not be the ultimate answer. With the rapid development of energy storage technologies, a new era of battery-powered tower access equipment is quietly emerging. These solutions may well become the definitive answer to powering tower service lifts in the age of ultra-high wind turbines. At 3S, innovation in tower service lift power supply systems has never ceased. Every step forward is driven by the same mission: serving hardworking people in a better way.